Hi guys, this is Carl, and this is week 7, problem 4. So we're going to get a little bit more complicated, but we'll go ahead and just kick it off. The question is, identify the population and the sample and tell whether a confidence interval can be used. So our question for this problem is: a medical device manufacturer is checking the production of its blood sugar device monitor. Research found that 11 devices, usually out of a sample of 500, do not meet the standards. They fail the quality inspections or what have you. How severe is this rejection rate for the company? So the population of the entire group is what we're interested in. And so what is the population given in this question? It's all sugar monitors. And so the true proportion is equal to P, which in this case stands for the proportion of all blood sugar monitors not meeting the standards. So when we're talking about whether or not a confidence interval is needed, so what does this mean? We want to find out that what is the range of successes. Now, key point here is that a success in this case is a failure. So, because we're looking at what is the range of the failures out of a sample at a confidence interval. We can reasonably, what's the interval of values that we can reasonably deduce and calculate that will present an estimate as far as the failures. Is it 11? Is it between 8 and 12? That kind of thing. That's what we're getting at here when we talk about the confidence interval. So a key question, whether or not we want to or we can use this confidence interval right here is it randomized? And does it meet the 10% condition? Now, the randomized, so what we can do, and it's a safe assumption, is if it's not articulated here, we can reasonably assume that it is randomized. Most samples of large scale are randomized. That's the whole goal, is to ensure a the integrity of the sample. Population surveys, it's a random sample. Political surveys, it's a random sample. It preserves the integrity, and it's actually allows you to better infer a large group opinion, even though you don't need to sample the entire group. So in that case, we are assuming, and we can assume, that this sample is random. The second point, the 10% condition. So what that means is, does this sample contain about 10% of the population? If that the sample contains more than 10%, there's our issues. Now here, let me explain a little bit. In a perfect world, you'd want to sample everybody to get the whole opinion, which is reasonable. When you're talking about cities, those kinds of things, that's ideal, but that is almost virtually impossible, given a whole bunch of limitations in terms of different access issues, people having an internet connection, people having a computer or lack thereof, people that don't have phones. The population is so diversified that you can't really expect to have a 100% sample rate. So if a sample contains about more than 10%, if it contains 20, 30, 40, 50, 60, what that means is that it leans into the potential for contaminants. What are contaminants in this case? Say, for example, where I'm at in Baltimore City, if you are sampling whether or not you like a certain area, whether or not you like a certain cafe, if you only sample half of the city, so let's say the Northwest Baltimore, if you sample Northwest Baltimore, you'll get about 80% response rate, right? And as a city, that could potentially represent 60% of the city. But is that representative of the city? No. So that's why you want to make sure this 10%, even randomized. So, 10% randomized is kind of the sweet spot in terms of making sure that you reasonably create a calculation that you can make statistical inferences about based on any kind of data that you're working with. So, our next step. So, is the sample size adjustment satisfied? A good key test is our NP, which is greater than 10. So what does this mean? This is our failures. It's counting our failures. So 11. So there we go. That's the first key. That's one of the key things that we've solved. Just real quick. And so for our number of successes, actually, our number of failures In this case, it's kind of flipped, so I apologize about the confusion. In this case, the success rate are our failures because we're looking at that as a confidence interval. The This piece is actually counting the successes or failures in terms of not being a failure. So what we just do for here is simply just the population itself. So we have a 500 sample and 11. So there, and as you can tell, both meet these conditions. This is greater than 10, obviously, and this is greater than 10, obviously. So what happens is we've met that condition. Another condition about the sample size. So as a result, a confidence interval for the proportion can be used. And so that will allow us to calculate this and figure out, okay, so what is the population? What is it? So it allows us to further get to know this. And so we'll be able to solve for confidence interval for proportion a little later, but I just want to give you a good brief discussion as far as talking out a question like this, where there's a little bit on the vague side in terms of, okay, is it randomized? Does it meet the 10% condition? So a lot of this is you kind of have to nail down the logic of it. But feel free to ask us any questions along the way. Thanks so much.